Hello everybody, this is Mr. Steele, and I'm testing out a new device to try to make some of these standards videos. I'm using an iPad that Mrs. Hubbard in the Green Academy was kind enough to give me to test out and use for this year. And so I figured I'd catch up on some of the standards that I haven't hit so far this year, including some of the Algebra 2 standard. Okay, hello everybody, this is Mr. Steele, and I'm working from a new device here to try to make some standards review videos. This time using an iPad that was given to me by Mrs. Hubbard in the Green Academy to help us work and try to integrate some technology into the classroom. So this is my attempt to make some videos here with an iPad, which is kind of cool. And so what I'm going to do is I'm going to pick up on the standards that I left off with on my original YouTube videos from the 2012 school year. And in particular, I'm going to start with standard number 9, which asks us to do some operations with functions. So there's two different operations that you're asked to do. One of them is finding an inverse, and one of them is composition. I'm going to start with inverses right here. So as you can see in this question, you're asked to find an inverse. Given f of x equals 3x minus 5, find f inverse of x. So we want the function that does the opposite. Instead of taking x and spitting out y, we want the one that spits out y if we're given x. So the biggest key here is to know about, or to think about when you're doing this problem, is to think about what it means to be an inverse. That is, it switches the x and y coordinates. So our trick, or what I'll call a tip, is we're going to switch the x and y. That's really what it comes down to. If you remember that trick, you can probably work your way through this problem. So what I mean is we're going to write our function, y equals 3x minus 5, with a y instead of an f of x, just change the notation a little bit. They're going to flip-flop the two variables. So we have x equals 3y minus 5. This, in a sense, puts the y coordinate, or the y variable, in the role of the independent variable. And so now we're going to figure out what is that function that does this, that does the opposite. And so it's as simple as then doing some algebra. Get x plus 5 equals 3y. Then divide both sides by 3. And we end up with x plus 5 over 3 equals y. Now what is y? Well, y is, of course, f inverse. This is the function that does things the other way. So we can rewrite it properly with the correct notation. F inverse of x equals x plus 5 divided by 3. And there we have the inverse of a function. Voila. Okay, now that we've seen the inverse, taking the inverse or finding the inverse of a function, in action, let's look at the other kind of problem that you can see on standard number 9, which is function composition. So here you're given two different function expressions. You're given f of x is equal to x squared plus 2x plus 5, a trinomial, and g of x is equal to x minus 3. So again, it could be other variations. You could be asked to do things in different order, but this is a pretty representative problem of function composition. Then it asks you to find f of g of x. So the way I think about it is I kind of help by looking here. We figure out what we're going to plug in to the other one. It's just like when you're evaluating and finding something like f of 1, in which case you just plug a 1 in each of these spots. Then you go f of 1 equals 1 squared plus 2 times 1 plus 5. Not very difficult, very straightforward thing. You've done it since Algebra 1. Here, though, g of x isn't just a number. It's actually an expression. So what we need to do here is we need to plug that x minus 3 into f of x. So first, or at least what I look at first, is like, okay, f of g of x. Well, f of g of x means we're going to take f of whatever g of x is. And g of x is equal to... Still getting the kinks worked out of this guy. G of x is equal to x minus 3. So what we really want to find is what is f of x minus 3? Well, from here, it's as simple as just plugging in x minus 3 wherever we saw an x before. So this was x squared, now it's x minus 3 squared, plus 2. Yeah. Perfectionist in me stands out. Plus 2 times was x, now it's x minus 3, and then all plus 5. So from here we've done it, like this is basically what we want to do. We just want to then simplify it a little bit. So what I mean is we can expand this out. This guy we can multiply out as a binomial. Having to know that x minus 3 squared is x squared minus 6x plus 9. And for the second one, you have to remember to actually distribute. So this will be plus 2x minus 6. And lastly, plus 5. So we've done two things. We've multiplied out the binomial here, and we've distributed it here. Now we've just got a bunch of stuff that we can combine like terms with. So it's pretty straightforward now. We've only got 1x squared minus 6x plus 2x is minus 4x. Then we've got plus 9 minus 6 is plus 3, plus 5 is plus 8. Now the question is, well, do I need to factor that? Do I need to simplify it? Well, you could, but in fact in this case it doesn't factor nicely, so we're okay. Instead we can just finish our problem out by saying that, oh, what was this? Well, this is f of g of x, and it's equal to x squared minus 4x plus 8. And so there is my final answer. It's just an expression. You don't set it equal to anything because it doesn't want to ask you to. So in fact, there we go. We've now seen everything that we might need on standard number 9. In the first case, we found an inverse just by switching x and y and then doing a little bit of algebra. And on the second one, we found the composition of two functions by plugging one into the other one and then just kind of algebraically working our way through. And so with that said, that covers pretty much all the different options you might see on standard number 9. Hope this video turns out, and I hope this has been helpful to you. So this is Mr. Steele signing off from an iPad. Have a good night.